this is supposed to be a mechanical measurements subject, what you have studied in the previous semester. Following that, this lab is intended to make you aware of what you have studied in the previous sessions. Okay, the subject, you want to do some practicals, how it actually works and all. That is what you are trying to have a look at this particular laboratory. All right. So today we will not start with the experiments, but I want to give you the overall list of experiments, how it works, how this lab is we are going to start, and how to, since it is a online motion, how we are planning it to continue, and what is the evaluation pattern and all. That is what I would like to share with you for today. Okay. So how many students have joined so far? Participants?
Around 110 students.
113 out of almost 160, correct? Out of 160. All right. So
few will join soon, sir. Like
which
10-20 more. Sir.
Which one?
10-20 students will join soon, sir. More.
But what about others? Will they be will they think that it will be automatically done, or what? I mean, attendance will be given, no need of joining these classes. I don't know how I will treat this lab. Last time I had a don't like the way that last time the evaluation has happened. Many doubts, so many questions were there. This time I think I will go a little bit correction wise, we will go a little bit the correct format so that the questions will be lesser. Last time I had to handle many students. Since I was a bit liberal, I think everyone thought that we can ask anything. Someone was writing, I have written very well, I don't know what is the mistake. Somebody has actually copied it, and finally they say that they have done an excellent job, and then they are deprived of a good grade and all. Please understand, since it is an online mode, and I understand the difficulties of the students, I was a bit liberal in the correction part in the thermal engineering lab conducted last semester. But somehow I could see that not everyone, but some of the students has a disagreement with that. So if you want the rules to be exactly like rules, we will follow that. That's absolutely nothing wrong in that. We can do that. Okay. But you have to understand that in labs it's a little difficult because there will be 180 students and it's not in a physical mode. And getting a different data set is different, so that the grading is becoming difficult for us. So how do we grade different students is one of the biggest challenge that we are facing, because the record that you are submitting is all the same, one and the same. There are not much variations in the record. So how do you ensure that there is a difference in the grading? So that is one challenge, and many of the instruments are not in working condition. That is what I am facing. Especially this particular course is one credit course, isn't it? We have only one credit for this particular course. And I would like to start with the list of experiments that we are going to carry out in this present semester. Okay. So is my voice very clear, right? We don't have any disturbance and all, right?
Yes, sir. It's clear.
Yes, sir.
Yeah.
Clear now, sir.
Yeah, the first thing is that we have 2 cycles. I am conducting the experiments in 2 cycles. The first cycle consists of 5 experiments, and the second cycle consists of 5 experiments. But the bad news I have to tell you is that right now we have only 4 experiments which are actually in working condition. Okay, but anyways, we are trying to buy new equipment to strengthen the lab. We are about to buy few experiments so that this lab will be strengthened in its full strength. It will work in full strength. But nevertheless, I am trying to find out certain instruments, or asking different faculty to provide their own setups to give you a feel of how these experimental setups will work and all. That is what I am trying to do. So the first cycle consists of the experiments which are actually in working condition. Okay, they are completely in working condition, and we can have the data and all. And we have these videos taken during the last semesters, which are good enough actually to explain. It was neatly done, so I don't think that those experimental videos what we have taken last semester will be handy for you to continue. Anyways, I will be here to explain any further doubts if you have, if at all you are having. Okay, so let us start with the cycle one. What are the experiments that we are having? The first experiment is air velocity calibration using hardware anemometer and pitot tube. So you all know that we have measurements of in your measurement subject you have studied the particular module called velocity measurement, and from the velocity measurement you will be able to measure the mass flow rate if at all you know the density of that particular fluid, isn't it? So if at all you know the cross sectional area, if you find the velocity by suitable instrument, you are good enough to calculate the flow rates, which may be velocity flow rate or mass flow rate, since mass flow rate is density into area into velocity, where velocity becomes important. So it can be said that this experiment can be in both ways. It may be air velocity calibration, or it may also be mass flow rate calibration. For both the things it can be used. Okay, but nevertheless, since we are using the instruments for velocity measurement, we have a hot wire anemometer. You have studied about the hot wire anemometer in your previous studies. Here we are having a vane type of an anemometer. Okay, so we have plates, and it is not a two wire or single wire hot wire anemometer. There will be a small rotational kind of a fan kind of a thing will be there, some blades and all. When the flow uh, takes place, let me on the video so that you can see my figure. So what happens is when there is a smile kind of flow that is coming through this, okay, there will be a small fan which is actually rotating because of the flow rate. Okay, the blades will get this jets will, or the flow will impact the blade so that it starts rotating, and we have a very smooth blade rotational movement. So for smaller velocities of 1 meter per second also, it will from 0.1 meter per second it will be able to sense it. But the problem with this, when it is rotated, this rotational movement of the fan is converted into suitable velocity. So that is the probe that we have, which we call it as hot wire anemometer. And you also know that the accurate flow velocity measurement can be done by pitot static tube. So we have a setup where we have a blower which is blowing air through a small pipe, and at the end through the pipe we keep a pitot tube which measures the stagnation pressure and dynamic pressure. From that you will be able to find out, based on the difference the height in the manometric liquid within the unit tube manometer, you'll be able to find out the head difference, and from that velocity is equal to square root of 2gh. You'll be able to find out the velocity of the flow, which is more of a standard kind of measurement, measuring the velocity. And once you measure the velocity of the flow through the pitot tube, you will be measuring with the help of a hot wire anemometer. And as you know, hot wire anemometer, time and again it has to be calibrated because it has having rotating paths and all. So we don't know, after a period of time, if at all we are using these anemometers, we are not sure how much error has kept into the instrument. So our work is to find out what is the difference when we measure the velocity of the flow through the pipe induced by the blower by using a hot wire anemometer and pitot tube, and later finding out what is the error that is involved. Okay, what is the error that has come, and by knowing the error, if we keep that into the expression, we will be able to actually calibrate the hot wire anemometer. Okay, so we will add the error that is associated with the hot wire anemometer measurements. How do we do that? And this will be helpful when you are actually doing any experiments in the industry or academia research. So this is the first experiment. You will go into deep of it when you actually do the video and get the calculations. You'll have a feel of it. All right, any questions in this? So there is a blower, and from the blower through a pipe there is a flow that comes out, and we are having a pitot static tube. Using that we will find out, which is connected to a U-tube manometer, and we are trying to find out the head h. Putting it in an equation, we will be able to find out what is the velocity of the flow. That is the standard. It's kind of a reference. And at the end of the pipe we are having this vane type blower or anemometer, and then this also gives some kind of reading. And what is the difference between the actual, that is pitot tube, and what is the measured, that is hardware anemometer? What is the difference between these two readings for a constant velocity? You'll be, with the help of this pitot tube, you'll be able to find out what is the error that is in the measured values of hardware. That is what you are evaluating through this experiment. Clear? Okay. The next experiment is the demonstration of torque measurement and do regression analysis. So you have a torque measuring instrument. So likewise, we have one single bar, one kind of a bar like this. And at the end of the bar, we have it is fixed to a particular thing, and this pipe is there. And at the end of it, there are weights which can be added to the end of the. So now you are adding the weight force to the downward direction through the beam, which is fixed on one end, and the other end is free to put the weights. Okay, and when you keep on adding your weights onto it of standard weights, which you know properly that the weights is exactly, you know the weights of it. So by adding each one of this, F into R is basically your torque. So you know from the standard equations what is the distance, perpendicular distance, and what is the weights that you are putting. From that you'll be able to find out the torque. Similarly, this torque measuring device is connected to a gauge, torque gauge, okay, torque measurement gauge. So that will help us, which is having the Wheatstone bit circuit and all. Through the strain, that gauge, you'll be able to find out what is the torque. So we have a standard way of measuring the torque, which we believe that it is not having any error, okay, standard. And we also have an electronic instrument which automatically or which digitally gives the torque values. So over a period of time, there may be differences in these two standard from the measured values. What is the error that comes in? And after finding out the data, you'll also fit a curve so that you'll be able to measure the torque very accurately with the gauge. Whatever the values that comes through the gauge, you will put it into the equation which you have got as a calibration or through your regression analysis. And by that, you'll be able to measure the torque. That is your second experiment. And the third one is basically your flow rate. As I told you, it is volume flow rate measurement. You also know the volume flow rate is basically measured in internal flows by means of orifice meter and venturi meter. Correct? But the problem with orifice and venturi meter, you all know that orifice meter will suddenly bring the system to a sudden halt. Therefore, if you remember the class, so this is the pipe, and suddenly we are actually.
Hello, sir.
It is not presented now. I'm just trying to present. Just a minute. So this is the pipe that we have, internal pipe, and we have, just a minute. So we have a pipe, and what we are doing is we are keeping a plate which is having a hole in between. What happens here is basically your flow that comes in will pass like this, isn't it? Your flow will pass like this. Okay. So there are small vortices which are forming over here, and this leads to the loss of energy. Okay, so whenever you are measuring by means of an obstruction meter, you are supposed to have the same pressure recovery, but unfortunately we have some energy that is being lost. So whatever you are measuring with the obstruction meters is not the actual but a reduced value. Similarly, we also have venturi meter like this, which is having a smooth transition like this, but still it's coefficient of discharge. That means its value is varying from 0.95 to 0.99. Whereas here your coefficient of discharge, which is nothing but what? Q theoretical by, so Q actual by Q theoretical sorry, this is Q theoretical by Q actual. One second, I just put a mistake. This value CD is coefficient of discharge is nothing but your Q theory by Q actual.
Sir,
Yeah.
it's actual by theoretical only, no, sir.
Actual by?
Yes, sir.
Yeah, correct. Sorry. Because it can be written anything. The only way is when its value is greater than 1 or less than 1, based on that we can always say.
Yes.
So you are correct. This is actual. Correct. Can be anyway. Only the thing is, in practice, what we assume in theory, what we assume is it is we are not taking the losses into account. We are assuming that there are no losses. In actual, we have losses. So always Q actual is less than Q theoretical. That is the idea of having CD. So because of this, what is happening is basically you are for orifice meter CD value is 0.6 to 0. Somewhere each textbooks give separately, so you can say that 0.65 to 0.8 or something around this range it will be for orifice meter, whereas for venturi meter this value is this much. So now we are not sure actually how much is the error from the standard one. Okay, but if you remember the rotameter that we have used, rotameter is generally taken to be constant this thing, right? So there is a tapered bar like this, you remember, and some kind of weight bob is kept over here. Okay, so there is no energy losses, but through the opening flow will take place, and it is nothing but it is working on the principle of your balance of the weight of this body to the buoyancy effect and friction force. Those are two forces. One is the drag and buoyancy. It is nothing but buoyancy plus drag force. So here we are not seeing much of a losses over here. It's just a balance of these two things. So we generally tend to take that rotameter is a standard one because we are not experiencing much of the losses here. So rotameter we consider it to be a standard one, and because of which we are comparing the measurements which are done by an orifice meter and a venturi meter. We are comparing with rotameter to find out the error associated with orifice meter calculation and venturi meter calculation for the same flow rate. Okay, so here it is only velocity calibration or mass flow rate. Here it is volume flow rate calibration. So we have considered three different properties of our flow properties measurement so far. And the fourth one that we are having is the pressure reading by electronic transducer and Bourdon gauge. So we have a pressure measurement setup inside where we have a hand pump kind of a thing by which we can increase the pressure. Okay, and we also have a Bourdon gauge which actually measures the pressure. So we try to, this electronic transducer which we are using is not the standard one, but Bourdon gauge we are taking it to be a standard one because whatever the pressure that comes in will be converted into mechanical means, and here we have an electronic device which is there. So we are trying to find out, we are assuming that the Bourdon gauge is accurate compared to the electronic transducer, and we are trying to find out what is the error that is associated with these two experimental things. So this is the fourth experiment. And finally, these four experiments are kind of ready kind of experiments, so I'm keeping them in the order. And we also have the thermocouple calibration. So this I have kind of asked different faculty. I have to request another faculty for who is generous enough to allow us to use this setup. So this experiment is useful for you for your research. Suppose you are bringing. What do you mean by thermocouples? Thermocouples are two dissimilar metals joined together at two, and when they are kept at two different junctions, EMF is produced, with which we are able to measure the temperature. Okay, so whatever the EMF that is generated, we are correlating it to the temperature difference, and if we know one of the temperature source, the other unknown source of temperature, we will be able to find out. But how do we ensure that the thermocouples measurement, whatever we are getting, is the correct one? How can we ensure what is the error associated with it? So in order to find this, we have first what we need to do is, what is the error associated with each thermocouple measurement we have to estimate. For that, what I am planning right now is we will have in our setup, in another lab, energy lab, what we have is we have a hot water bath. Okay, we have a hot water bath in which we have water. We have water which is maintained at a constant temperature. Okay, water is inside, and by means of a heater, particular heater, what they are trying to maintain is it is maintained at a particular constant temperature by proper stirring apparatus and all. These are called as hot water baths, where it can be, the temperatures can be maintained from 0 to 80, 0 to 100, depending on, suppose if you are going more than 100 degrees centigrade at standard room temperature, we will be going for different oils because water boils at 100 degrees centigrade. So we will use different oils. So this is called as hot temperature bath. So in this, we are keeping an RTD. So RTD are generally considered to be the accurate when compared with the thermocouples, correct? Resistance temperature detectors. So, and whatever the thermocouples we want to put, we will keep it these thermocouples. Okay, and connecting it to a data acquisition system like this, DAQ. So now for a constant temperature, I will set a constant temperature here, for example, 20 degrees centigrade. Once it reaches the 20 degrees centigrade, a very high precise instrument called RTD will show you 20.1 or 20.5 or 20.05 degrees centigrade, for example. What is the effect? What is the temperature that will be read by the thermocouple? So is it giving 21, 20.9, whatever it is coming. So we will type of plot for different temperature, for different temperatures. Okay, RTD versus thermocouple. Okay, so this is like an input versus an output. So from that you will get a curve, and by regression analysis I will find out how the relation between them is, whether it is linear, whether it is not non-linear. We will find out what is the expression is. So this will help you to estimate the error associated with the thermocouples. And these are very, very relevant whenever you are doing an experiment related to temperature. You are asked to find out the uncertainty out of that experiment, out of the whole experiment. So you need to have that uncertainty measurement through this particular experiment. So these are the first cycle experiments, which I believe will be able to, 4 experiments will be able to do this very quickly in 4 weeks. And then 5th week, we will try to have this thermocouple calibration experiment. Okay, and we have at the end of this, we will have a quiz just like in the thermal lab for 15 marks. Okay, which is likely the similar way we have for the thermal lab, but it's not true or false. It's like more or like what we call fill in the blanks kind of a things. It's not MCQs. We have good number of TAs, so uh, this you have to be prepared. Okay, this particular lab. So many questions may come from the measurement subject also. So don't expect only from the experiment, even though it is related to that, not something new I will give. Suppose if there is a question from hardware anemometer or pit or tube, that will be relevant to the text, whatever you have studied, only on that it will be given. Will not be very tough, but at least you have to look at the textbook. That is what is expected of you. So this is the first cycle, and then in the second cycle, these are all the things that I am planning. I'm not sure how far I can do, but I will try my level best to make sure that you will have a look at this so that you'll have a feel of the lab. That is what I'm trying my level best to do. The sixth experiment we are planning is the demonstration of temperature measurement by infrared thermal imaging camera and its calibration. This is one of the best thing I am expecting. See, now you are suppose thermocouple will help us to measure only the surface temperature at a particular location. Correct. Suppose you have a surface like this, and if you want to find the temperature at discrete locations, you will be able to find out with the help of thermocouples, okay, at these locations. But what if the whole system, how the temperature will be varying along this line, everywhere, what is the field is complete. How do you get the temperature profile of this, which is continuous in nature, whereas here it is discrete? So for that we use the thermal imaging camera, thermal imaging scanners because of COVID and all. Now I have the thermal imaging camera which works on the principle of which principle it works?
Thermal radiation.
Yeah, radiation principle. But radiation principle is very much dependent on the emissivity of the object, isn't it? Radiation is dependent on emissivity, how the emissivity is. Correct. So you may get some value depending on the what input you are giving for it as an for the emissive values. But how do you know whether your emissivity you are guessing is the exact emissivity of that material? How can you ensure that? For this, what I'm planning is I will have one particular thermocouple, okay, a thermocouple which is connected to a data acquisition system here, DAQ, which can measure the temperature of the. So the bottom we will have some, this is a copper plate. Imagine that this is a copper plate, very thin copper plate, Cu plate I'm writing, copper plate. And we have a heater at the bottom, heater. So this will we assume that it will uniformly heat this. After waiting for certain steady state, so this thermocouple will give the temperature at this particular location. Similarly, by using the camera, thermal imaging camera, IR camera, we will try to measure the temperature of this at this location by taking the image or by getting the images. So now we go on increasing the temperatures, and go on taking the pictures, so that we have for different temperatures we have both thermocouple as well as thermal imaging camera recording values. So after calibrating them, you will be able to find out what is the correct emissivity, which if I give as an input, it will give the same value as the thermocouple. So this
Sir,
is
one
what,
doubt.
yeah.
We are using thermocouple to find temperature at a point, no sir.
Correct.
When we remove that thermocouple, can we say that temperature will be same as that? Like due to atmosphere, it can cool down also, no sir?
Why you are taking out? You are not taking out. You are keeping the thermocouple on the surface, and the same you are also taking, because you are using a copper plate. What is the use of a copper plate?
It
It is
has
having
high
very high.
conductivity.
So whatever the temperature that you are giving, if you wait for sufficient time, what happens?
Steady
A very
state.
thin. It's a very thin plate. That means what is the conduction? What is a mode of heat transfer? One dimensional, 2D,
One
or 3D?
dimension.
So when it is 1D, can we expect in that region around that it will have the same temperature or not? More or less.
Okay, sir. That means the thermocouple will be at the bottom, and from top we will take the photo.
Exactly. At the same time, we
Okay.
will be taking both of them. Okay.
Okay, sir.
Camera is here and the surface is here. Next to that point, we will take. Exactly, you have want to take. There are other issues. See, if you kept a thermocouple, and how do you connect it with some grease or something? What is its thermal conductivity? Again, contact resistance.
Very less. And
Again,
resistance
contact
will be high.
resistance. So it's not as simple as we are talking. That doesn't mean that put a thermocouple, it gives you complete temperature values and all. But for you to get a feel how difficult in the instrumentation part to get an accurate value. So that is what you have to appreciate. You will be able to appreciate. So when you do these kind of experiments, you will understand what is there. Taking just an instrument value, there's nothing. You don't think, no. So this, if it goes according to what I'm planning, I definitely feel that you'll be appreciating this particular lab. That's what my plan, and I'm working on it. But I'm not sure. The professors may not give the instruments. It all depends on them. So I'm trying my best. Let's hope things will work in that way. Okay, so that is the 6th experiment. And we also have the 7th experiment, which is pressure calibration using deadweight tester. You have studied about this particular thing. We also have the deadweight tester, but it is not in working condition. So for this, what I'm planning is this deadweight tester working is available. I've shown you in the mechanical measurement lab. So what I'll try to do is how it works. I will, if some video I will take out, because anyhow it's an online mode, and whatever the recordings or what data that we have, I will provide you the data, and from that data you should be able to calibrate the using the deadweight tester. I'm sure that since it's an online, you are not touching any instrument. How does it matter whether the instrument is here or somewhere? So I'll be working with some other institute where this deadweight tester is there, and I'm trying to get that data. So I kept it as my 7th experiment. Okay, and 8th experiment is an interesting one. This is basically, you have studied the first experiment. First thing that you have studied is for classification of instruments into 0th order, 1st order, and 2nd order. So here what we are trying to do is for a different signal inputs, for example, sinusoidal, rectangular, these kind of inputs, how the 1st order system will behave. You want to figure it out in the graphical mode. So there is a module that I found which will be for a given amplitude, frequency, and time constant. It will give you how this behavior will happen. Okay, so this kind of you have to download one small software into your system, and then you should be able to figure out on your own, so that it will be a different kind of an experience. I feel like it's like online mode of experiment, virtual lab kind of a thing. So where in your own system you will download those two softwares, and for different inputs what you are getting, you will be able to figure out how the behavior of the system, what is the governing equation that will come, everything you will be able to see. Okay, so this is our 8th experiment. Okay, and 9th experiment is basically to we have this LVDT setup. You know the LVDT. What is the use of linear variable differential transformer? What is its use? It is used to measure the have you studied it or not? Are you there? What do you mean by linear variable differential transducer? Why it is being used? It is used to measure the distance or the displacement. Okay, so we have a micrometer which is mostly accurate one, like the vernier calipers. The micrometers are mostly it's a least count is something around 0.01, so it's most accurate. So what we try to do is we have a mechanical gauge which is micrometer to measure the displacement. Similarly, we also use an electronic gauge which is LVDT, and we also trying to compare it. What is the error associated with LVDT with over a period of time? How to measure it? Suppose if you are using an LVDT which is digital in nature, you will get the values. But before starting the experiment, you have to be absolutely sure that there is no error, or you should be knowing how much error it is coming through the instrument. For this, it is kind of a calibration kind of a thing. And finally, this is a study experiment, thermal conductivity measurement setup. So this is one of the faculty is having the thermal conductivity analyzer, which helps us to find out the thermal conductivity of PCMs, phase change materials. But I don't know how far because some kind of expertise is required to operate this instrument. So we are at this point of time, I'm keeping tentatively it as a study experiment. Okay, that How we can measure, I will kind of demonstrate it through a video, but whether we will be able to work on it or not, I'm not sure. So I'm planning to do that. Okay, so this is my 10th experiment. Okay, so total 10 experiments. At present, we have 4 solid experiments. The all other I have to find out ways and means by which we do the 10 experiments. So that's why I'm not started this week, because 10 experiments only we have, and we have good amount of weeks following. So right now, one experiment every week will be sufficient. Okay, that's how we will follow. This week I'm not giving you any experiment. The other challenge in this area, you cannot copy because there is no manuals for all of this. So you have to work on your own and write down. Okay, so I can give you some of the specifications, but what is the theory, what is its, how do you work on it, and that you have to take from the experiment, I mean video, and then from that you should be able to write down whatever in your own words. And so that's how I want to conduct this experimental this lab of this measurements lab experiments. Okay, so any questions up to this, you feel free to ask me. And then following the 10th experiment, we will have another quiz which is also for 15 marks. Okay, so similarly the same thing, it may be MCQs, it may be fill in the blanks, depending on whichever I feel comfortable. I will put these 2 quizzes, okay, which will help me to differentiate the students or grade the students. The main essence of this particular quizzes is to grade the students, nothing else. Okay, for the academic audit. And finally, we have the evaluation pattern. So your internal quiz, I am keeping it for 20 marks, 15, 15, 30, and I'll consider it for 20 marks. Record, because good amount of record work you have to do. You cannot simply copy and put. So if at all you do that, there will be deduction of marks. So you have to be on your own. When I say that it is a kind of same thing written, means it should not be line to line copying. Every line, if it is the same, is, are, o, put it some kind of difference, you show it. I don't mind it. But if you want to put the exact wordings to even some last time one student has not changed the name of the person who sent it also. So don't do such kind of a things. And so record evaluation is for 30 marks for 10 experiments. So what 10 into 10, 100, and I will grade it to 30 marks. And finally, your external exam is for 50 marks. This is the pattern that I'm thinking right now. Okay. Any
Sir,
questions?
in the end exam, I think 50 marks is very high, sir. Like
Why?
last time we had experiment to write the experiment, no, sir.
Hmm.
One experiment and one theory.
Hmm.
What happened was most of the people got very like small experiments with no graphs and everything.
Hmm.
That was very easy to complete, so they got lot of time for theory question. But
Okay.
I myself got a graph of four graphs, sir, 4 or 5 graphs.
But I'm sure the graphs are only 2 graphs are given last time. It's not 4
No, sir,
graphs.
I got four. At least four or maybe five also.
Okay. At
I
least this
think
time we
it
will
is
try to
constant
manipulate.
speed Perkins engine test.
But here we don't have, we have only one calibration curve we will have, and one regression analysis for each of the experiments. What extra you will have? We
Yes,
are
sir.
not
I'm
doing
not
anything.
telling like that.
Ah,
Like there is difference in the work of the
see,
like
things are
when
like you
people get
cannot,
different things. How can we evaluate fairly, sir? Like when the
that thing
marks
can
are
never
50
do it.
marks.
See, you have JEE exam every day, the same kind of exam questions are being asked. So when you are having different times, are you questioning that? Some may get easy questions. How do you specify that the standard of question is same? There may be someone who is getting a different difficult question, and sometimes the question paper, even for GATE, sometimes the question on one day the question paper is very simple, people say, and other time it will be tough. How can you say that? So no, nothing is fair. I'll try to standardize the paper, normalize the paper such that everyone, but it's impossible for making uniform for everyone. Okay.
Okay, sir. Okay.
That's what we can do. Even if you become a faculty and all, this this normalization of things will not be so easy as you say. Okay, I understand your query, but things will work like this time you got tough, but in other subject you may get easy when compared with others. That's how it gets normalized, but not that everyone will get the same thing. Anyways, I will take consider this. Anyways, we will talk to by the end of the external, by the end of this lab, we will be able to decide. No, it's not that uh, you don't have any say in the format of exam, is it? We always have, we always
Yes, sir.
discuss,
Yes, sir.
right? Because this is whole and soul. I am the in charge, so I will take decisions. So don't worry about it. Okay, if you find something is not justifiable, we will change it. What is it? Okay, this experiment may be for 30 and again 20 marks for some quiz kind of a thing. I may keep it, right? So don't worry, though that comes at the end. Okay,
Okay, sir.
right? So we will discuss, and once you agree for that only we will go. All right. So no worries with that. But record submission, you be thorough. Okay, in time you try to submit the record and try to be on your own. Okay, it cannot be word to word copy. Please avoid that. I cannot say copying. Don't do that thing. Okay, I'm telling you. Suppose if I have to grade, I have to be so strict. Last time many people has given me very bad time. Thought of being very strict, but since the number of experiments are not there, so I don't have that chance. If I have some 8 experiments at least, I would have shown you how the experiments, how the lab will be completed. But nevertheless, we will try, guys. It's like we will try our best to. I'll try my level best to show something new. If it is possible, you enjoy it. If it is not possible, then also you try to understand. Okay, there is no dearth of effort from my side. I can guarantee you that. Last time, these 4 experiments, uh, let me off the recorder. Last time, how we have done, these are the 4 experiments they have conducted. Okay, these are the 4 experiments. First week, experiment will be, recording will be shown. Second week, your data will be given and you are doing calculations. Likewise, 4 to 8, that's it. That's what has been, that's what happened in the last measurements lab. Okay, so at least we are trying to put something new. If things comes out, appreciate it. If doesn't comes out, understand it. Don't try to mock me. That's what I'm doing. All right, so we will, any questions I would like to take, otherwise we kind of stop at this point of time. Any questions, guys? Just let's start from the next week onwards, our first experiment. Beforehand, I will send you the. Do you want me to play the recording here, or should I send it to you directly? Which one you prefer?
Send it to us.
Hmm?
Send it, sir.
You can send the recordings to us, like before the session.
If
Before
anyone
the,
has some doubts, we can ask.
but anyways, I'll also play it in the. So we have to at least engage you 1 hour, no? So don't you think that it should be played in the lab also?
Yes, sir. That's also fine.
Okay, I
But
will
before,
send
if
it.
you'll send, it will
Yeah,
also
I
be
will
nice.
send it, and the manuals also, as I told you, only for few things manuals are there. So somehow I have to manage with that. So let us see. Okay, I am the in charge of this. So don't worry, whatever you feel like for the rest of the experiments. For the first 4 experiments, we do have manuals. For the rest of the experiments, we will find out somehow. Okay, what I'll do is I'll try to put every Wednesday both the recording as well as the manual. Go through it. So once we enter the lab, look at the recording once again, and then you ask whatever the questions you have in terms of calculation part is not there too much. Only thing is you have to look at the recording, and if you have anything in doubts in the experiment and all, you can ask. This is not like thermal lab where you have so many other things. It's only simple that you have a calibration curve in each of the experiment. Okay, so one standard and one automatic, one measuring thing. So you are always comparing the measured value with the standard value and finding out what is the error. That is the complete experiment of things. Okay, so if you have any specific questions, please. There is any question? Can you put 40 marks for NSEM? Yeah, Akshay, this is 40 marks only, but only 10 marks we have to give for Viva or something, no quiz or something. So exam will be for 40 marks and 10 marks for the quiz. So the rules says that 50 marks for external, 50 marks for the internal. That's why I put like that. If there is a provision that I can reduce to 30, I can do that. It's not an issue. But what the rule says is 50 marks for the external exam, 50 marks for the internal. So that's how you have to evaluate. Okay. Any more questions? At least say that you don't have somebody.
Clear, sir.
Yeah, it's clear, right? Okay. Okay. Let us see what we can do in the coming weeks. Okay. Okay. Please be in time. Who are the TS here? How many TS have attended? Let me check. So TS.
Yes, sir. Navam Srivastava.
Navam Srivastav has come. Yeah. Next.
Soumyaranjan Das, sir. Soumyaranjan Das, sir.
Ranjan Das. Yeah, I saw you.
Sir Sachin.
Who is that? Anil is there. Anil is there, and
Sir Sachin Chandragaon.
Sachin Chandragaon is there. Okay.
Yes, sir.
Next, 4 people only.
Sandeep, sir.
Sandeep Vajja, correct?
No, sir. Sandeep Mantri.
Sandeep Mantri. Okay. And Sahit should be there, no?
Yes.
Sandeep.
Yes, sir. Sahit, sir.
Yeah, Sahit is there. And others? Only 3, 4, 5, 6 people. What about others? Did they come?
Vivek should be there, I think.
Vivek Mishra, are you there?
Not there.
Vivek, instead of Vivek, Anil has joined. They have swiped their labs actually. They shared them and they changed their labs. So Anil is not there. Any other one? Anil is there. So who are the other ones? So these are the people who has attended, right? I'll talk to others. Okay. Okay, I'll tell you. We will have a meeting in the TS. How to go about it. Both PhD and MTech students. One Sahit, Sandeep, Sachin Chin, Soumya Ranjan, those no 6 people. That's it. Okay, then for the time being, I'm actually closing the session. Okay, we will meet next week with the last experiment. Okay, Wednesday I will upload the both. I will share both the audio as well as the video. Okay, right. Okay, take care all of you.